Hi friends, today we are gonna do lab 3.3 in AWS Amazon SageMaker, and let's start. This lab is about automobile data sets, and the data given us here as a CSV file, and this CSV file has lots of attributes for a car and lots of car sample, as you can see. Now let's continue from here. First of all, we will import the data and explore it. For that, we are importing pandas library in Python. Then we are taking this CSV file. It's actually locally in here, so we didn't use URL. Actually, this URL is belong to this notebook instance, and in here the feature names are given to us, and it will read the CSV file and give the column, make the data frame for that. This data frame car shape will give us how many samples we have. We have 205 samples car, and each car has 25 attributes. This method will give us return the top five samples in this CSV file. Let me run that. Actually, maybe I should take all of them. Now, as you can see, it will return us the top 5 cars in that CSV file, and these are our attributes, features for that cars. So to display information about the column, we use info methods. Let me run this. When we run that, it will give the attributes data type. For example, for assembling, we are using integer. For normalized losses, we are using float, and for the others, we use object. For example, for field type, for example, for field type, it can be either gas or diesel, so it's a categorical data type. So we can say that when the data type is object, it means that these data are categorical. For example, number of doors are categorical. It can be either 2 or 4, and body style also, and drive wells. It can be front wells drive, or 4 well drives, or grave well drives, depending the tree situation. Now let me continue, and also we have 205 entries, but for some of them some null variables. For example, normalized losses, we have lots of null variables, and as you can see in here, four of them is null, and for that as well, there is no data entry in 4 car. So in here we will drop the columns that we won't use now. Let me run these codes. Now we have for columns aspiration, number of doors, drivable-ways, and number of cylinders. We will use these four attributes. Now I'm gonna run this column, so it will give for the top 5 cars in the CSV file, it will return these attributes. So for example, for the first car, the number of cylinders is 4, and for the third car is 6, and number of doors, as you can see, aspiration is standard for the first 5 car. Now we are gonna do encoding ordinal features. Ordinal means that we can say that, for example, 4 is higher than 2. We can compare them. We can find distinguish them easily. We can map them like that. So let me just run here first. It will give the infos already, and let me run here. It will give the value counts for the cars. For example, the 114 cars has 4 doors attributes, and the rest of them is two doors. Now we can replace this string 2 as a numerical value 2, and this 4 as a numerical value of 4 to encode them. Now let me run here. Yeah, we now did this. Now we will get which is the equals if 2, it will instead of string 2, it will gonna replace with numerical 2. Run. As you can see now, I'm gonna run this block instead of giving a string 2 or 4 in here, 2 or 4, it will gonna give integer value, numerical values. Did I do a mistake? No, it gives in here, as you can see. Now we are gonna do, for example, we can do this as well for number of cylinders. Number of cylinders can take 2, 4, 6, 7 different variables. It can be either 6, 8, 12, 5, 4, 3, or 2. So we can give them a numerical variable. We can replace them. Now for that, we will do the same thing. Just run here, and run here. As you can see, for the cylinders, for it replaced with this numerical 4. So we encoded these number of cylinders as a cylinders feature. Now, how about we encoding the non-ordinal categorical data? These non-ordinal categorical data like, for example, drive wells for four-well drive, or front-well drive, or rear rear-well drive. We can't compare them with a numerical data. I mean, you can say the 6 cylinders is higher than 4 cylinders, but you can say the front wheel drive is bigger than or higher than the four-wheel drives. And for these type of categorical data, we're gonna do one hot encoding, I think, if I'm not wrong. Let me run these columns, and on that columns from here. Yeah, this is one hot encoding, like I said. Actually, these drivers is just one feature, but for these drivers features, we are gonna create additional two features for the categories. For example, if the car is rear wheel drive, we are gonna give one, and the rest of them will be zero. We will encode them like that. We will make this one attribute as a three attributes. And now we will go on with aspiration. The aspiration could be standard or turbo. Let me just run this code. Yeah, it gives standard and turbo. For the 168 cases, it's standard, and the rest of them are turbo in our car CSV file. And when we are gonna do encoding for this categorical data, there's just two values this aspiration can take, standard or turbo. So we can represent it just the binary. We can say that for example, for STD it will be 1, it will be or 0, and for turbo it will be 1. Now this code is make them as a binary classification. Let me run this code, and after that we will run that code. Now, as you can see, the aspiration turbo is when 0, it means that it's a standard. So if it would be an if it would have turbo, it will replace them. We just replaced here with just 1. So that's the end of the log. Thank you for listening me. See you in the next step.